What's up, team? Quick question before we start. Do you actually know model selection, matching foundation models to business tasks? By the end of this video, you will. Let's dive in. A Series B startup burned 2 weeks of provisioned throughput budget on a model that cost twice as much for identical results. Today, we'll walk through the decision framework that would have caught that mistake in 5 minutes. The 5 attributes experienced engineers filter on, the context length rule that decides between a 32K and a 128K model, and the endpoint names you'll reach for again and again on Databricks. In Episode 1, we mapped the Databricks generative AI stack and met model serving, the layer that exposes large language model endpoints to your agents and apps. In Episode 2, we learned that prompt engineering is usually the first fix you should try. Today we tackle model selection, for when the task itself demands a different tool, not just a better prompt. Now that you've seen what's at stake, 5 terms to anchor the rest of this video. Context window is the maximum number of tokens, prompt plus response, that a model can attend to at once. Encoder only versus decoder describes whether a model reads text to produce labels and embeddings, or whether it generates new tokens. That single distinction rules out entire families of models in one step. An embedding model maps text to a fixed size vector for similarity search, and it is not interchangeable with a generative language model. A pay-per-token endpoint is a Databricks hosted model exposed under a predictable name, billed by the token, and the model card is the marketplace listing where license, context window, parameter count, and benchmarks all stored in one place. Here's what happened in detail. DataDino's machine learning lead spent 2 weeks A/B testing Llama 3.1405B on a fossil record summarization job. The summaries were good. The problem? Llama 3.370B produced summaries that were just as good, at a fraction of the cost. 2 weeks of provisioned throughput budget vanished into that experiment, and for a Series B startup, that money matters. Here's the part to sit with. The 405B wasn't the wrong choice because it was big, it was the wrong choice because nothing about the task actually required it. This is the rule experienced Databricks engineers live by. Reach for the smallest model that meets the requirement, not the biggest. Every other decision in this video flows from that sentence. The skill is not knowing which model is most powerful, it's knowing which model is sufficient. The misconception on the left is intuitive, and it's wrong. More parameters do not automatically mean better answers. The flagship is not always the right pick. Quality does not scale linearly with size, and over-provisioning is not a safety net. It's just expensive. On the right is the working norm. Start with the smallest viable model, escalate only when benchmarks demand it, match the model's attributes to the actual task, and treat cost and latency as quality dimensions in their own right. A model that's 2 times slower and 5 times more expensive for the same output is, from a system perspective, a worse model. So how do you choose deliberately? You filter on 5 attributes. First, task type. What category of work is this? Summarize, classify, generate code, or embed. Second, context length. How many tokens does the model need to see at once? And on Databricks the options span from 512 up to 128K and beyond. Third, language. English only, or multilingual. Fourth, license. Does this model permit commercial use, or is it research only? And fifth, benchmarks. Not the headline leaderboard, but how it scores on your task family. Filter on all 5 before you deploy. Every common model selection mistake is a case of skipping one of these boxes. Filter number 1 is task type, and naming the task correctly is harder than it sounds. Compressing a paragraph into a 1-sentence gist is summarization, not a sentence-sizer, which just splits text on punctuation, and not classification, which assigns a label. Assigning a label to a piece of text is text classification, and encoder models like BERT are excellent at it. Writing new code from a description is code generation, and that points at the code llama family. Finding similar text is an embeddings problem, which produces vectors, not generated text. The most common way engineers pick the wrong model is by mislabeling the task at this very first step. Here's the analogy that makes architecture stick. An encoder-only model is a book reviewer. It reads a passage and produces an opinion about it. That's classification, sentiment, and embeddings. It cannot generate new text. DistilBERT is the canonical example, and it caps at 512 tokens. A decoder or encoder-decoder model is a novelist. It writes new tokens, one at a time. That's summarization, chat, and code generation. This is what generative actually means. Llama, DBRX, and MT5 all stored on this side, and their context windows reach 128K and beyond. The engineering rule is simple. If the task is read and label, pick an encoder. If the task is write new text, pick a decoder. Asking DistilBERT to summarize a document is the wrong job description for the architecture. 3 reasons rule DistilBERT out of any generative scenario instantly. It's encoder only, so it has no decoder to produce new tokens. It caps at 512 tokens, so even a moderate document overflows it, and it was never designed to generate text in the first place. When you see DistilBERT offered as the answer to a summarization, chat, or code task, that's the wrong answer flag. Here's the picture I want you to keep. Context window is the size of your desk. A 512 token model is a sticky note, fine for one paragraph, hopeless for anything more. That's DistilBERT. A 32K model is a normal work desk where you can spread out a report. That's DBRX instruct. A 128K model is a conference table where you can lay out a full 200-page contract at once. That's Llama 3.370B and Llama 3.1405B. And a 400K model is the boardroom table. That's the ultra-long context tier. Things like Gemini 1.5 class. The rule is simple. Size the desk to the document, not to the model's reputation. If the document doesn't fit on the desk, the model can't see all of it at once. Full stop. Memorize this one. If the requirement says process a 200-page document, or summarize a long contract, or reason across an entire report at once, reach for a 128K context model. On Databricks, that's Llama 3.370B or Llama 3.1405B. Short paragraph or chat turn. 32K is plenty. Let's walk that rule through real numbers. A 200-page contract, at roughly 400 words per page and 1.3 tokens per word, lands around 100,000 tokens. DistilBERT at 512 tokens is disqualified immediately by 2 orders of magnitude. DBRX instruct at 32K is disqualified by length alone. It's a strong model, just not for this job. Llama 3.370B at 128K is viable and fits the whole document in a single pass. Llama 3.1405B at 128K is also viable, but more expensive for the same outcome. Following the smallest viable rule, you start with 70B and only escalate if benchmark quality fails. Straight from the Databricks documentation. Meta Llama 3.370B Instruct is a state-of-the-art large language model with a context of 128,000 tokens, built by Meta, multilingual, and optimized for dialogue use cases. 3 attributes packed into one sentence: 128K context, multilingual, dialogue tuned. That's why this model is the de facto default on Databricks for most generative workloads today. With the core framework locked in, task category, encoder versus decoder, and context length, let's work through the remaining filters. License and language come next, then we'll cover embeddings, the marketplace, and the endpoint names you'll actually call. Filter 4 is license, and when a scenario asks for open source and commercially usable, here's the answer set you want loaded. DBRX, Databricks flagship mixture of experts model. MPT, the original Mosaic ML family. The Llama family from Meta, Dolly 2.0, which we'll touch on in a moment, and MT5 when the requirement is multilingual. On the wrong side, DistilBERT is open source but encoder only, so it loses on the generative requirement, not the license. Proprietary GPT class APIs are not open weights, and Alpaca, Vicuna, and Koala are tainted by OpenAI output contamination in their training data, which blocks commercial use. Research-only weights without a commercial license are also out. Dolly 2.0 deserves a closer look because of why it matters historically. It's a 12 billion parameter instruction-tuned model based on Eleuthia AI's Pythia. The real story is the training data. It was fine-tuned on Databricks Dolly 15K, 15,000 prompts handwritten by Databricks employees, specifically to avoid any OpenAI output in the training set. The dataset is released under Creative Commons B by SA 3.0. That clean lineage made Dolly 2.0 the textbook example of a model that is open and commercially viable end-to-end, code, weights, and dataset. Here's DBRX straight from the docs, a state-of-the-art mixture of experts language model trained by Databricks, outperforming established open-source models on standard benchmarks, and strong on summarization, question answering, extraction, and coding. The architectural lesson here is the mixture of experts design, a pattern where the model routes each token to a small subset of specialized expert networks, rather than activating every parameter for every token. That's what lets a model with very large total capacity stay efficient at inference time, and it's the idea we'll unpack in the next scene. DBRX by the numbers, and remember, we're looking at this as a historical architecture example, since the pay-per-token endpoint was retired in April 2025. Thanks to its mixture of experts design, only 36 billion parameters are active for any given token. The total parameter count is 132 billion. According to Databricks benchmarks, DBRX inference runs up to 2 times faster than Llama 270B on equivalent hardware. Despite being almost double the total size, you're paying compute for 36 billion, not 132. The context window tops out at 32K tokens. That 32K ceiling is what would have disqualified DBRX for the 200-page contract scenario we just walked through. Interesting architecture, wrong desk size. When the task is explicitly code generation and quality matters, Code Llama is your default pick. It beats a generalist like Llama 270B, and an embedding model in that slot is a category error. Under the hood, it's a Llama 2 derivative fine-tuned on code, supporting Python, Java, C++, TypeScript, PHP, C#, and Bash. It ships in 3 flavors: a foundation model, a Python-specialized variant, and an instruct-tuned version. And it was trained on 16K token sequences with extensions up to 100K, so it can hold a substantial codebase in context at once. Here's the decision rule. Plain and simple. On Databricks, multilingual generation means Llama 3.370B. That's the multilingual generative workhorse on this platform, the endpoint you reach for whenever the requirement crosses languages. If a scenario asks you to summarize support tickets in French, Spanish, Japanese, and German, that's the model. As background context, MT5 is the well-known open-source multilingual architecture, a text-to-text transformer covering 101 languages, and you may see it referenced in older material. But it is not a Databricks-hosted endpoint. The actionable rule on this platform is one model, Llama 3.370B. Now the category mix-up that trips a lot of people up. Embedding models map text to a fixed size vector, and they power retrieval, similarity search, and clustering. The names to know are BGE large, GTE large, Databricks GTE large N, and Databricks Qwen 3 embedding 06B. They cannot answer questions. and they cannot summarize. On the right, generative language models cannot replace an embedding model for retrieval. That's the first thing to lock in. What they do is generate new text token by token, which is what powers chat, summarization, code generation, and the answer step in a RAG system. Llama, DBRX, Code Llama, and MT5 all live here. The decision rule: if the output is a vector for search, pick an embedding model. If the output is text for a human to read, pick a generative model. Swapping one for the other is a category error that shows up often in scenario questions. Think back to retrieval augmented generation from episode 1. RAG is not one model, it's two roles. The embedding model finds the right chunks in your vector index. The generative model writes the answer from those chunks. You pick both, never one in place of the other. A scenario that mentions retrieval and answer generation in the same breath is asking you to name a model for each role. 2 Databricks hosted embedding endpoints to know by name. On the left, Databricks GTE Large N, 1024 dimensions, 8K context window, English only. That's your default for English RAG workloads. On the right, Databricks Qwen 3 Embedding 06B, configurable 32 to 1024 dimensions using Matryoshka representation learning, meaning you can truncate the vector at request time to trade storage for recall. 32K context, 100 plus languages, and it's the default when retrieval is multilingual or when inputs are longer. We're not going deep on the chunking trade-offs here, that's the next video. A quick visual reinforcement of the two numbers worth committing to memory for Databricks GTE Large N, 1024 embedding dimensions, and an 8192 token context window. When a scenario gives you those two numbers, that's the model. Where do you actually look up these attributes before deploying? The Databricks Marketplace model card. Think of it as the nutrition label for a model. On the listing for Databricks Meta Llama 3370B Instruct, you can see at a glance, license is Llama 3 Community, commercially okay. Context window, 128,000 tokens. Parameters, 70 billion. Multilingual, dialogue tuned. Benchmarks on MMLU, Human Eval, GSM 8K and example notebooks linked right in the listing. All 5 filter attributes in one page. Engineers who skip the model card end up with the wrong model in production, every time. And here's the docs explaining why this curated set exists in the first place. Databricks has pre-installed a selection of state-of-the-art foundation models with permissive licenses, optimized for serving via the Provisioned Throughput Foundation Model APIs. The phrase to anchor on is permissive licenses. The legal review your company would normally pay a lawyer to do has already happened for every model in this set. That, plus the serving optimization, is why the marketplace is your default starting point before reaching for anything external. These are the endpoint names you'll use in production code. Let's lock them in. On the generative side, the active pay per token endpoint is Databricks Meta Llama 3370B Instruct. 2 more you'll see in older code and documentation, but should not call in production: Databricks DBRX Instruct, which was retired in April 2025, and Databricks Meta Llama 31405B Instruct, retired in early 2026. On the embedding side, Databricks GTE Large N and Databricks Qwen 3 Embedding 06B. The pattern is always Databricks-provider-model-variant. The one detail that trips people up: hyphens everywhere, no dots in the version numbers. It's 3-3, not 3.3. If you see a dot in the endpoint string, it's not the Databricks endpoint name. One heads up worth knowing: Llama 3.1405B pay per token was retired in February 2026, with provisioned throughput retiring in May 2026, a 3-month gap. So if you have legacy code calling 405B through provisioned throughput, You have a hard deadline. Always verify current availability in the Databricks changelog before relying on it. The platform is, in effect, enforcing the smallest viable rule by removing the easy escape hatch. Llama 3.370b is now the de facto default for most Databricks generative workloads. DataDino's 405b experiment couldn't even be run today. And here's the whole flow in one picture. Step 1. Name the task category, summarize, classify, generate code, or embed. Step 2. Figure out how many tokens you need to see at once. Step 3. English or multilingual. Step 4. Does the license allow commercial use? Step 5. Does it benchmark acceptably on your task family? Then pick the smallest model that passes all 5, and escalate only if benchmarks actually fail. That's the workflow that would have saved DataDino's 2 weeks of budget. 6 things to take with you. Name the task category exactly before naming a model. Encoder only is not generative. DistilBERT cannot summarize, chat, or code. Size context to the document. 200 pages means a 128K model. RAG always needs both an embedding model and a generative model, never one in place of the other. Memorize the active endpoint names, Llama 3.370b for generation, plus the 2 embedding ones, and remember that both DBRX and the 405b endpoints are retired. And above all else, reach for the smallest model that meets the requirement. DataDino spent 2 weeks learning this the expensive way. With this checklist, you can run the same filter in 5 minutes before you deploy. Now let's put it to the test. Question 1. A product team needs to convert each customer support email paragraph into a single sentence gist for an analytics dashboard. Which task category best describes this requirement? Is it A. Text classification, B. Sententizer, C. Summarization, or D. Embedding generation? Take a moment to think about it. The answer is C. Summarization. Compressing a paragraph into a one-sentence gist is the textbook definition of summarization. A sententizer just splits text on punctuation. Classification assigns a label, not new text, and embeddings produce vectors, not readable summaries. Naming the task category correctly is always the first step in model selection. Question 2. A teammate proposes deploying DistilBERT as the model behind a customer-facing chat assistant. Why is this the wrong choice? Is it A. DistilBERT is a proprietary model that cannot be commercially licensed? B. DistilBERT is encoder only with a 512 token context cap, so it cannot generate text? C. DistilBERT only supports English, and chat assistants require multilingual support? Or D. DistilBERT requires provisioned throughput, which is too expensive for chat workloads? Take a moment to think. The answer is B. DistilBERT is encoder only. It has no decoder to produce new tokens at all, and it caps at 512 tokens of context. Either reason alone disqualifies it from any chat, summarization, or code generation scenario. Remember the book reviewer versus the novelist, wrong job description. Question 3. A startup needs a generative language model that is open weights, commercially usable, and available as a Databricks-hosted endpoint today. Which option best fits these requirements? Is it A. GPT class proprietary API, B. Alpaca, C. Llama 3.370b instruct, or D. DistilBERT? Take a moment to think. The answer is C. Llama 3.370b instruct. It's open weights, commercially licensed, and it's the current Databricks-hosted generative flagship. Remember, DBRX instruct pay per token was retired in April 2025. So even though DBRX is the famous Databricks-built model, Llama 3.370b is what you actually call today. GPT class APIs are not open weights. Alpaca is tainted by OpenAI output contamination in its training data, which blocks commercial use, and DistillBERT, even though open, is encoder only and cannot generate text. Question 4. A legal tech team must summarize 200-page master service agreements in a single model call without splitting the document. Which Databricks-hosted model is the most appropriate choice? Is it A. Databricks DBRX Instruct with 32K context, B. Databricks MetaLlama 3370B Instruct with 128K context, C. DistillBERT with 512 token context, or D. Databricks GTE Large N with 8K context? Take a moment to think. The answer is B. Databricks MetaLlama 3370B Instruct. A 200-page contract at roughly 400 words per page is around 100,000 tokens, which fits inside a 128K context window. DBRX at 32K and DistillBERT at 512 are disqualified by length alone, and GTE Large is an embedding model, not a generator, so it's a category error. Following the smallest viable rule, Llama 3.370B wins. Question 5. An engineer needs to call Databricks hosted general text embedding model for an English RAG workload. Which pay-per-token endpoint name is correct? Is it A. Databricks GTE Large N, B. Databricks.gte.large.n, C. Databricks Meta GTE Large N Instruct, or D. Databricks Qwen 3 Embedding 06B? Take a moment to think. The answer is A. Databricks GTE Large N. The naming convention is Databricks-provider-model-variant, with hyphens throughout, never dots. The instruct suffix in option C belongs on generative models, not embeddings, and the Qwen 3 endpoint in option D is the multilingual embedding model, not the English GTE1. Hyphens everywhere. That's the pattern to lock in. That wraps up model selection, matching foundation models to business tasks. The Databricks GenAI Engineer Cert has more videos coming on the trickier topics. Subscribe so the algorithm tells you when. Thanks for watching.